Exercise 185, page 466, question number 12. So we've got to do an integral in here to find ZR, Z subscript R, to do with rigid motors apparently. I've never seen this formula before. We've got to do an integral between 0 and infinity, which is an interesting one to have a look at. And also the exponential term has got lots of constants in it. H squared over 8 pi squared I kt. All of those are constants, which makes it look really horrendous, but we can simplify things by letting k equal all this constant here, and that will make the working out a lot easier. So the first thing I would do was let k, which is the constant effectively in this, equal h squared over 8 pi squared I k t. And that's a common little step to try and simplify the algebra as you're going through, and then we can just replace k with all that stuff afterwards. So this means I can rewrite the integral a bit more straightforwardly and get that z subscript r equals the integral between 0 and infinity 2j plus 1 e to the minus j plus 1 k, and then respect to j. Now looking at this exponential function, this part of it here, the exponent, we need to let part of this be u to make it an easy one to do. That's the bit I'm going to play around with to that equal u. Looking at it, I know that if I were to multiply out that bracket, I'd get j squared plus j. And when I differentiate, I'm going to get 2j, which means I might be able to cancel out the 2j at the front. So what I'm going to do is to multiply out the brackets and then let that be the u, and then differentiate that and see how I go from there. Put that substitution in. So you might like to try it for yourself, and I'll carry on working it through below. So ZR equals integral between 0 and infinity of 2j plus 1 e to the minus k, putting that in front, and then that's all multiplied by j squared plus j with respect to j. So now if I differentiate, if I let u equal j squared plus j, and differentiate du by dj, I get 2j plus 1. That's looking promising because that looks like this. So it looks like there's going to be some cancelling going on, which is good. So if I now rearrange for dj, dj equals du over 2j plus 1. So putting this information in and following the normal routine, ZR equals the integral between 0 and infinity of 2j plus 1 e to the minus k u, because I've let u equal j squared plus j, and then I'm changing my integral to du over 2j plus 1. And lo and behold, the 2j plus 1 terms cancel, and so I'm left with ZR equal to integral between 0 and infinity e to the minus ku du. And that is a standard integral. So I've got to do that standard integral and then put in the limits of infinity and 0. So if you want to carry on and see if you can do that from there. ZR equals, integrating the exponential, we get e to the minus ku over minus k between 0 and infinity. Now bringing the minus k outside the integral, we get zr equals minus 1 over k e to the minus ku between 0 and infinity. Now we have two ways to go. We can either change the limits or we can replace u with what we set u to be. That's probably the easiest thing to do in this case. So what do we let u be? J squared plus j, or j into j plus 1, might be more convenient. So zr equals minus 1 over k e to the minus k j into j plus 1 between 0 and infinity. That's probably the easiest way to think of it, because then we can think what's going to happen if j equals 0 or j equals infinity. Also, the minus means the inverse, so finally I'll replace e to the minus with 1 over e to the k j plus 1, and that's going to make a difference when we think about putting our limits in of 0 and particularly infinity. Okay, so try it from there. Think about what happens when you put 0 in and when you put an infinite value in. Zr equals minus 1 over k. Now putting infinity in first, I get, if that's j is an infinite value, then effectively going to get 1 over e to the infinity minus, now if we put 0 in, j equal to 0, we effectively get e to the 0. So zr equals minus 1 over k. Now, e to the infinity obviously is an infinite number, and 1 divided by an infinite number is 0 if you think about it, because the infinite number is an extremely large number, and 1 divided by a large number gets smaller and smaller until in the limit that ends to 0. Anything to the power 0 is 1, so that's just 1 over 1. So we get, inside the limit, all of that actually collapses to minus 1. And so suddenly zr equals 1 over k. All we need to do now is replace k with what we set k to be, and in fact the answer is just the inverse of that, so that's going to be the inverse of k, which is 8 pi squared IKT over h squared. So 8 pi squared IKT all over h squared.